Good evening, sir.
Hey, hello, hi, good evening, everyone.
Yeah, good evening, sir.
Okay, I think we are a bit delayed, but that's fine. Okay, uh, just give me 2 minutes. We'll start immediately. Okay, yeah. Hello, everyone. Let's start now. Okay. Is this the final attendance? What is the reason behind low attendance? Like usually, I can see like 25 to 30 people, but today are less. Fine. Any idea about it?
Not so sure, sir.
YouTube recording is started. Okay, you are saying that that's because of that only people are not joining. Okay, okay, no issues. So all of you have started with week 7. Low
Yes,
marks.
sir.
What happened?
Is the result declared for
Not
first
yet.
quiz?
I don't think it is public yet, but from our side we have checked it. It's done. Probably in couple of days it will start, but
Tomorrow, I think by tomorrow or day after tomorrow,
yeah,
it
it
will
will
come
get
back.
released. Yeah, from our side, it is declared already. It was like fair result. I guess 50% of the students have passed. I think, yeah, 50 or little over 50. And average marks are also around 50, if I'm not mistaken. Just let me see what is the point.
Sir,
So, how
in
was
this,
your quiz? Okay, let us discuss that first, maybe. Right. So, what was the? Yes, I am upset. Okay, Vic
yes,
saying, what is the reason? What do you think? What happened? Okay, let okay, maybe we'll discuss maybe a bit for 15 minutes. We'll try to understand. But paper was easier. I didn't think that it
Yes,
was
sir.
too difficult.
no, sir,
Probably, sir.
it was moderate to
According.
difficult.
Yes, sir.
What is it?
It was moderate to difficult, difficulty level.
Difficulty was. I don't see it was difficult. I think it was
I mean,
moderate. I can say. Okay, I have the result with me. Okay, okay. I think pass percentage is low. 44 is the pass percent in MLT, and average score is around 40.
around 40.
There are 45
That is,
students who are in between 90 to 100 bracket actually.
sorry,
There are like around 45 students who are between 90 to 100. So if I can say that above 70, there are around 250 students who are about 70 marks. Okay, fail percentage is higher. Uh, 907. Okay. Can I just understand what are the difficulties you faced or challenges you faced during the paper? Well, I hope all of you have gone through the answer keys release, so you have some idea about what are your marks in MLT, right?
Yes, sir.
yes, sir.
So yeah, what do you feel? What is your assessment over it? That I wanted to understand.
Sir, from my point of view, I think
Do you feel
Some
the syllabus is hard, or you don't understand the concept because of that the mistake happened, or because see,
it
I think numericals or
it
the
was a sir.
yeah.
Yes, sir. Actually, it was a mix of both.
Hmm.
So, like I thought that I could perform PCA questions,
Hmm.
but at the time of exam, I was completely blank and I didn't perform well in that questions, and also that GMM and cluster questions also.
Okay. Shall we see
That
what was
also
the
I
paper? How was the paper? Let me check. We'll see the questions possibly. Will that be okay, or you wanted me to start with the week 7? Week 7 is easier, so we'll start anyway. But let me understand what is the difficulty so that we can MLT, right?
Yes, so can I say
Yeah, yeah, yes,
for
Abhijit.
yeah, so for me the problem is not something great, but while understanding the concepts and theories, it was easy for me to grasp things
Okay.
topics like linear regression and all,
Hmm.
PC and all. It was easy to grasp the topic,
Hmm.
but sometimes I had faced a problem in applying things.
Okay.
Yeah, so whenever I try to solve the questions, I sometimes get stuck over the questions, how to do, how to solve next, how to go to another step. Sometimes if one value comes, then what to do further and all.
You have your response sheet with you, right? The question paper
Yeah,
also is there.
yes,
So,
yes,
answer key is released, right, sir?
yeah, yeah. So I
Response sheet. Okay.
okay. So I think the first one was like very straightforward, right? It was nothing.
yes. It was easy. It was
K
really
means
straightforward.
clustering. Which of the following points will definitely? I think it was little difficult question. Question two.
Sir, in this question, why 0, 0 will not come, sir? I
Uh,
plotted the graph and I
okay,
tried
100%.
to.
If I have to read the question, K means clustering is run on a data set of three if you know that the points are a part of the same cluster. Okay, and which of the following points? Actually, you will have to see the distances, right? So 0, 0, I don't think it was that. So you have to choose k equal to 3, right? 3 points,
Hmm,
and which
three
all three
points.
points among these A, B, C, D will be. So how will you choose? Okay, if it was a part of the cluster, the distance between these 3 points also should be minimum, right?
Lower minimum, yeah.
I think zero
Actually,
zero
we
is
didn't
not.
cal
I don't
actually we
Actually,
think.
didn't
Sir, if
calculate the
you draw it
distance
on,
and I draw it in the graph.
Uh,
So I was getting the 0, 1 and 1, 1
uh,
as a line,
like
and
yeah, correct. They are on
it
the
was a
line.
line.
Hmm.
Uh,
But now
but
if you see
then
that 0, 0.
I was confused in C and D option.
So
0.2 and 1 was
uh,
coming on the line,
okay, let
and 0, 0.
okay,
Yeah,
let us
sorry.
no,
see that.
actually, if you drew it on paper, you would see that the point C, it actually lies between the two given
Yeah,
points.
correct. And that is
Exactly,
that is
and
Uh,
that is why
so
it is in the same cluster.
that is the most sorry, okay, I'll have to adjust my vacuum here. Okay, so let us try to understand this part. Maybe this is your number line, and I think let's say 0, 1 is here, right? The one point is here, right? 0, 1, and possibly 1, 1 will be somewhere here, right? Let us try to draw other points -1 and 1. I don't think this is a question, or this is the point of contest, right? -1 on x-axis and 1 on the. So this point might be
are you
here.
drawing it? Are you
Yeah.
drawing something?
Am I not sharing my
Is
screen?
it not visible?
Oh, I think I just shared tab. Right. Is it visible now?
Yes.
Okay, so this is the first point. This is another point, right? This 0, 1. This is 1, 1. The red
Hmm,
colored is -1, 1.
hmm.
The next is 1, 2, right? So +1 on x-axis and 2 like somewhere here. Draw red points here, somewhere 1, 2, and then we have point 2, 1. So point 2, 1 basically lies here, right? So point 2 on
Hmm.
x-axis and 1 is here, right?
Hmm.
and the last one is 0 0. So if you see, so what is your understanding of these 3 points? So
So
which is
first
the
two
most
points are
possible, yeah, most possible cluster here?
so sir, first 2 points are not lying. They are not in on the line of the first 2 points. I mean the points which are forming the cluster.
Mm,
Regarding the point which is red dot, which is coming between the two blue dots,
mm.
that is the most appropriate. But yeah, I was
No, what is k
confusing.
minus plus plus algorithm gives you is that your cluster center will have the minimum value, right? So,
Hmm.
so when your distance between the clusters, between the points, like whatever the cluster you are having, and whatever the points inside that clusters are having, their distances should be minimum compared to their cluster center, right? So, if I choose a
Hmm.
cluster, this as a cluster one, right? So if you see that the cluster center will be somewhere here, let us say, right? Maybe slightly
Yes.
very closer to this point. And if you see
Hmm.
the distances, it will be lesser, right? If I choose the cluster to be, let's say, these 3 points, right? I'm just excluding this point. What happens now? Will this have the minimum uh, center cluster, like cluster center? That is what the task of K-means algorithms, right? The mean value should be the distances of the points from the cluster are minimum, right? So if you see that these 3 points, if I join with this cluster, they will not have the uh, so most likely cluster is this one, right? These 3 points, if you try to draw, is that fine? Okay, I think for that you
Hmm.
will have to understand this part. What is this? This is a Lloyd's algorithm, which is a k-means plus plus algorithm, right? And
Sir, the
how
cluster mean can be anywhere, right? The cluster mean can be anywhere. The question is that if the 2 points 0, 1 and 1, 1 are part of the
cluster,
uh,
yeah,
cluster,
uh,
then any point in between the 2 points will also be a part of the cluster,
correct,
because if you take the center, if you take the center as any point in the 2D space,
yeah.
the distance from that center to the 0, 1 and 1, 1
Mm,
and zero point 0.2 and 1,
mm.
0.2 and 1 will be in between the distance between the mean and the 0, 1 and 1, 1. So that is the reason I applied
No,
that
but yeah, that is true. So here, what is the important discussion is your distances from the cluster center should be as minimum as possible, right? That is the one of the
Hmm.
important part, right? Otherwise, see, otherwise that point will be assigned to other cluster. Is that correct? So if
Hmm.
these 2 points, I already given these two blue points are the part of a same cluster. So now the next point cannot be like very away from that these 2 points, right? Otherwise, if it is very away, so if you see that, right, this point and this point, they may not be the part of that cluster. If I have this point to one, because let's say these three are already on the line, and this definitely will give me the so what will be its cluster center here if I have these 3 points? The cluster center will always be on that line, right? On this line joining these 2 points.
Yes.
Correct, right? Or no?
Yes, sir.
Yeah. So that is what that is the reason this point to one is a better point. But if I use this Lloyd's algorithm, right, or K-means clustering algorithm, it will give. It is most likely that this point to one, will be the cluster, the part of that cluster. That is the understanding here, right?
Hmm. So one doubt here, sir. Um, Suppose in my cluster there were 3 points, let's say 0, 1, 1, 0, and 1, 1.
Mm,
And now out of, I mean, my k was 4.
mm.
And now if I have to choose a fourth point, will 0, 0 be a part of that cluster?
Sorry.
I'm saying that if I have 3 points in my cluster
Huh.
let's say 0, 1, 1, 0, and 1, 1. And now if, and my k is 4, and if I
Huh.
have to choose the fourth point,
Huh.
then was the 0, 0 my
I
answer
think
in that case?
then that is a possibility, right? Or I think all other are then maybe zero
I mean,
zero.
I'm trying to create a
Yeah. So
square here,
if k equal
square
to
of
4,
point.
right? So I think
Hmm.
possibility is there. The maximum we'll have to check with the distances, right? It
Hmm.
is possible that this point also may qualify. Or
Okay.
I think I will see if I think if you
So
just
it should always be a part. It
yeah
should, suppose we take the mean in the first quadrant.
yeah
Suppose we take the mean in the first quadrant.
uh.
Suppose the mean is in the first quadrant.
No,
Then
see,
0, 0 will not may not be a part of the cluster here.
K-means algorithm when it is saying, right, it is not about, so it is not about the initialization of the K-means cluster or the mean. It is like after the iterations happen, where is the possible mean? That is the understanding. Okay, I think what you are talking about is the where I can start with the cluster. So let's say if I start with the mean somewhere here, right? I think you are talking about that, right? It is not the case. So eventually it has to be uh, like the k-means clustering. When I said here in this question, that means the algorithm has run through some iterations already, and now once it is settled down, what is the possibility that among these 4 points which will qualify for that cluster c1? Okay, that is the understanding
Hmm.
of it.
That which will definitely be a part of the cluster. That's the question here. So 0, 0 can be a part of the cluster, but the question is, will it definitely be a part of the cluster?
Yeah.
That may not always be the case, because 0, 0, suppose we take the, suppose the cluster mean is in the first quadrant,
Hmm.
then suppose it is in the first quadrant, then 0, 0 may not be a part of the cluster, because the 0, 1 and 1, 1 are part of the cluster. So that the distance of 0, 0 from that mean is higher than the distance of
0.2 and
0,
1.
1 and 1, 1 from the
Correct.
uh, so,
Correct.
but a point
Hmm.
in between these 2 points, suppose a point in between these 2 points, that is 0.2 and 1, the distance of this point from the mean will definitely be in between the distances between 0, 1 and 1, 1. So the word definitely here is very important, I think. So it is possible that 0, 0 may also be a part of the cluster, but it will not always be a part of the cluster,
Correct.
whereas 0.1, 0.2 and 1 will always be a part of the cluster, provided 0, 1 and 1, 1 are part of the cluster.
Correct.
That's what
So
the question is here.
why it will happen is because k-means plus plus algorithm is not the will not always give you the optimal cluster centers, right? It will get converged at some point, but that may or may not be the optimal clusters. But if you see that any point between these two, it should always be the part of the cluster if it is k equals to 3. Now if you talk about k equals to 4, then I think all these 3 points, right, they may qualify for that, but still the chances of getting this point and this point uh, of that like becoming the part of that cluster c1 will be higher than the this point when I'm talking about k equals to 4, right?
So here I think
Hmm.
the k does not matter. K does not matter here, I think.
No,
Will the
k
k
should
matter
matter.
It
here?
doesn't matter. K matter.
K should matter, right? if
Yeah,
if
No,
otherwise,
the number of clusters we are forming is irrelevant. We are only talking about the cluster which is having 0, 1
Oh,
and
okay, okay,
1,
okay.
1.
K equals to 3 here. Okay, sorry, sorry. K should have, okay. K is the number of clusters, right here. No, it's I was thinking about K nearest neighbor. Okay, fine. K equals to 3 here means K equals to, these are the number of clusters, right? It is not
Yes,
number of neighbors. Okay,
yes.
sorry about it.
number
So
of clusters.
the
Yeah.
number of clusters means so there are 100 data points. K equals to 3 means these 100 data points actually are going to be into three clusters, three different clusters. Okay,
Hmm.
but in that case, this is the more probable chance, like or more probable that these 3 points will be the part of the cluster one when k equals to 3. or
Hmm.
maybe I
K
think,
K
yeah,
does not
K
matter
doesn't
right
matter here.
Then
here.
Yeah, because it is
Why
a
does K
chemist.
matter here?
No, no,
I
it,
don't
it does not.
understand why K matters.
No, no, it doesn't matter.
Means
That is
K
for
might
sure.
be anything.
That is for sure. Okay, that is okay. So K doesn't matter because it's not a K nearest neighbor algorithm. It's a K means clustering. I was that impression in my mind that it's a K nearest neighbor algorithm. But okay, but among all these 4 points, right? The more probable point, which is be a part of the cluster C1, is this one because it's on the line of that these two, right? So
hmm.
that is for sure, right? Okay. What about this? I think this is a little bit trickier. I think with respect to its, I think how it is written there. But if you follow the uh, whatever algorithm we have seen, right? Or maybe the proof which we have gotten for I think PCA, will be able to answer this part. What about this question number 4? Do you face any difficulty in question number 4? This is a kernel matrix, right?
Yeah, sir. In this, how? Yes, sir. How we
So,
can solve this
so how
question?
can we say that there is a Mercer's theorem, right? What Mercer's theorem say about kernel matrix? Uh, the
It should
matrix
be
should
symmetric.
be symmetric, and another part is it should be positive definite, right? And you
Yes.
just have to check which of these matrices are positive definite. And for so if you just look at through like the options, the B option will be discarded like very quickly, right? Because its first element, which is the first pivot, it's negative, right? So we can directly
Hmm.
discard option B. Now remains with the A, C, and D. Now one of the properties of positive, like how will you say that whether it is positive definite or not? You just have to find out its determinants, right? And if the determinants are positive, then it is positive definite, right? Or equal to, or maybe you can find out its eigenvalues, but I think finding out eigenvalues, it will take time. So determinant finding is the easiest way to approach this problem. All right. So first, for let's say for first matrix, the first determinant is 4, which is positive. For the 2 cross 2, it is 20 minus 1, which is 19. So that is positive, and then remaining again for entire matrix, you can find out it is positive. So option A is straight away that it is the most appropriate matrix, right? Like that, you'll have to solve.
Mm.
Okay, I
So
think
symmetric. If the matrix is symmetric, then also we can say that it's an appropriate matrix for X
yes, yes,
transpose,
yes,
right?
yes, yes, yes. So that is the first condition. Uh,
Symmetric
it is a necessary
symmetricity like
condition. Yeah, it is a
A
necessary
transpose
condition, but
equal
it is
to
not
A.
sufficient. Yeah, yeah. So here you can see option C. It's not symmetric, right?
Mm.
So you can discard this also. So B and C you
Mm.
can straight away discard. The only choice happens between A and D, and I think they are both
Okay.
right. Okay. Oh, fifth. I don't think you have faced. Do you face issues here in the fifth question? A and B are definitely these are the examples from the I think it's from the lectures itself, right? This Gaussian kernel, right? This is polynomial kernel. What about C? C, because the eigenvalues of x transpose and x transpose x are same. That means the trace also because trace also should be equal. Why? Because what is the definition of trace? Trace of any
Sum of the
matrix,
eigenvalues
sum of
of them.
eigenvalues, right? So if the eigenvalues of x transpose and x transpose x are same, then their sum will also be same, right? And that should be equal to trace of the matrix. So option C should be correct. What about option D? Even though they have the same eigenvalues, they may not have the same eigenvectors, right? And we have seen that our during our I think the theorem we tried to prove, right? So I think that's why option D is wrong. Fine. See, maybe I can feel that maybe option where option A you can have issues, but other options you shouldn't have the issues, right? Did you face any challenges here in question 5? Okay, silent. What about
Can't,
option?
we can't.
Question six. Question six is very easy, right? You just have, there is a point we have given, and you just have to find its projection onto the first principal component. So the point is 3 4. The first principal component is, let's say, w1. So it is kind of like this, right? So this is the principal component, which is w. There is a point here, and you just have to, I think the point is 3 4. Unit vector is given to us, which is, I think, some root 2 by 2 or something, that, right? What should be its projection here? So let's say this is x, so it should be x transpose w, right?
Hmm.
That is the answer actually. So already
X
transpose
trans.
matrix was given to you. X
I
transpose
tried to
w,
calculate it, but my answer was
like
coming
x
as
transpose w or w transpose x, both should be correct, right? Because the scalar dot product is commutative, right?
hmm.
So anyway, it should be correct. It should come as
Yeah,
that
my
answer.
answer was coming in 7 as 7 point.
So there may
I
be
did.
your calculation mistake, right? So it's like it is 7 by root 2, right? So root 2 by root 2 is basically 1 by root 2. Here it is 1 by root 2. And if I multiply
So
with
it
3, 4, it is 7 by root 2. 7 by root 2,
hmm.
right? Correct?
7 root 2 by 2.
Uh, Yeah, that means, yeah, 7 root 2 by 2 is
Yeah,
basically 7 by root 2, right?
7
So,
by root 2.
and that
Yes.
should be your answer. So it was easier, right?
Hmm.
This was easier question.
Yeah,
Question 6.
I missed this.
This one also. See, that's what I think. See, that's how you're, see, this 3 points question. That means it's like you lose around 7.5 marks, right?
8 marks, sir. 8 marks.
Eight.
Yeah.
It's
Yes.
it's a
14
40
marks.
marks question, so it is 2.5 times, right?
Yes, sir.
So seven
I
and a half.
think the calculator given in the dashboard is a bit difficult to
So
handle.
in the exam also we were facing difficulties in calculating, I
But
mean, using
seven
that
by root
Normally, we
two.
are
calculator.
using the normal calculator, which is much easier to use. But
It was very much
the
slow, sir, there.
Slow, okay, but why?
Slow in the sense that to press the numbers and because
But
we have
here,
only the
okay.
mouse, right?
But question six, you just have to enter two things, right?
And
Seven.
I understand, sir, that was my
Okay.
mistake, I admit.
Okay.
But I think that the calculator was not to the
So
mark
okay, we'll
because
see. Okay, I
we
think.
have
Okay.
practiced those.
Correct, correct. I
Yeah.
understand the part, but let's say first one question, this question, the third one, the fourth one you might need, but I don't think you can do it like by hand also. Fourth one, fifth. So among six questions, you have not much of the calculations involved, I feel. Seventh, seventh. What was the question? This is the like similar question to your graded or practice assignment, I guess, right?
Yes, sir.
Uh, I don't know whether if you've done the mistake there also.
Sir, I got 0.03 in 8.
Where? Third question?
Question number 8, sir. 8.
8. 8
8.
was, I think, 8, yeah, 8 because this answer is given. So this is a mistake from our side, that because this answer is given using uh, uh, like normal distances, right? Like
Yes, sir.
in the square, the square root, actually we'll have to see for square root of the distances. It's Euclidean distance, right? So
Yes, sir.
when we calculated the answer, it was actually calculated using the squares only. So we kept it, this square root of 0.09 is I think 0.003, right?
Yes, sir.
But I think marks has given to that also, that answer also. So both of the answers the marks has given. So those who have written 0.09 and those who have written 0.003, it was
Yes.
because it's a square root of the distance, right? Or square root of the length or something.
Sir, it will come 0.03. Means it was also solved in this course by TS.
Okay, okay, fine. I think so it is, this question was little bit tricky, I guess, or no. Here we just have to find out the probabilities, right? So
Yes,
we'll
sir.
have to find out the total distance, and what is the answer? What is the point at the first cluster mean? Find the probability. So it, here we have two clusters, right? K equals to 2, and if one is a first cluster mean, then find a probability of the point that has the least chance of being chosen as a second cluster mean. Yeah. So you will have to find the distances. from all points from that 0.11, right?
Yes.
And then you will have to see that whether which is having the highest probability. And I think, but why? Okay, use Euclidean distance to calculate distance to find a probability. Oh, the probability is asked, right? Okay, okay. Probability is basically, yeah, it will change. So I think you find out the distances. Uh, so for, let's say, 1 0 and 1 1, what is the distance here? It is 1.
1.
And the total distance, I don't know how much it is coming. One, here you can see it's 4. 1, so we have calculated like 1 plus 4 5,
Yes.
like that. And it should be coming, it should be written as, let's say, 1 plus 2, right? Square root of 4.
Yes, sir.
And here also it is 1
1
plus
plus 9.
9, so root 10. It should be root
Yes.
10, and we have
Yes.
taken only 10. So that's
Yes.
why the change in the answers are there.
Yes, sir.
All of you are able to solve this question, right? I think it is solved everywhere, I guess. In the discourse also it is solved. But yeah, it is possible that you might have got the wrong answers there. Okay. What about question 9? Question 9, I think a lot of people have got confused because of, I think some of you didn't take the first 4 tosses, right?
Yes, sir.
But this is like, it was not a conditional probability, right? You just, when you wanted to find out the log likelihood, you have to take all the tosses happened. So I think total of 9 tosses happened, among which 8 were heads and one was the tail. So the likelihood will be 1 minus p to the power 8 into p, and then the log likelihood will be uh, 8 times log of 1 minus p plus log p, and then you just do usual things, right? Here the some of the people I think wrote like 1 minus p to the power 4 into p, and that's why the wrong answer is there. What about 10? 10 was okay, 10 was a difficult question, I think. It was not difficult, but I don't know. You will be able to solve this. It is like total probability in the denominator, and the probability which, let's say it is belongs to first component.
It's a Bayesian rule used for
Bayesian rule.
calculating
Yeah,
lambda.
we have done
You're
in this.
calculating lambda. Basically, to calculate lambda here.
Yeah, correct. So I think this kind of questions we have done in stats 2 also. It's not, were you able to? I don't know, man. You guys have to tell me whether you failed this one. What about this?
It was easy, sir.
This was easy, right?
Yes.
Representative that has unit length. This was like, we can just definitely say that it's 1 by 1 2, right?
Yes, sir.
So 1 by root 3 and 2 by root 3 should be there. What is the answer? Oh, root 5, sorry. 1
1
square plus 2
B.
square, 4. 1 by root 5 and 2 by root 5. This. What is the variance along the first principal component? It should be the lambda, the highest eigenvalue of the covariance matrix, right?
Yes.
So first of all, you will have to center this data set, and after centering, you will have to find out the covariance matrix. So what will be the covariance matrix? 1 by 4 XX transpose, right?
Yes, sir.
And then that matrix. So I think that was this answer is correct, or is it wrong? I think not.
Correct, sir. Correct.
Yes,
Sir,
no?
I
Okay.
also got the same 18 point.
Okay. What about this question? This was the regular question from stats 2, right?
Yes, sir.
Posterior distribution. It's like you have to find out likelihood first, then the prior is given as a beta. So what is the beta prior? So beta is the prior for p. So it will be, I think, p to the power. What is the prior?
So it was 1191, sir.
Huh?
Acha, which one you're saying? 1191 beta?
What is the beta distribution basically for this
Yeah, 1191, sir.
Beta is giving 1 1.
1 1? So it will be like p to the power 1 and 1 minus p to the power 1, right? Or what is it? What is the beta distribution? I forgot the beta distribution.
P to the power alpha minus 1, 1 minus p to the power beta minus 1.
So basically it is 1, right? E to the power 0 and
Yes,
1
e
minus
to the
15.
power. So the probability, the
So distribution will be like
distribution will be zero.
likelihood. So it will be basically based on the likelihood only, right?
Yes.
Okay, fine. What about
That is alpha by alpha plus beta, sir.
yeah? This is posterior mean. This is like alpha. That is it. So where you did wrong? I don't understand. You guys are giving answers here. Who? So I think okay. Genuinely, if I see that, I can say that the calculations are involved. Maybe here, right? These 2 marks, these 3 marks, 5 marks, and let us say here, how many? 5 plus 4,
Sir,
9,
question 9 was tough, little bit tough.
9. This one.
Yes, sir.
Why?
I didn't get it, sir. It was little tricky. I just put
Okay.
0 0.2.
Okay. 0.2 because I think you didn't take
I,
the first four tosses.
yes, sir. I didn't take first four.
Okay, okay. Let us try to understand. So let's say this is 2 marks question. If I say it is numerical based, how many are there? 2 plus 3, 5. 5 plus 4, 9. 9 plus 3, 12. And here let's say 12, 3, 18. This should have been correct actually, right? I will not consider this as a like very numerical based, but 12. This also was easier. Uh, okay, let's say 15. 15 means okay. 15 means how much you have lost. If it is 30 and 37.5, yeah? Okay. But not many questions are there, right? Okay, possibly the exam pressure will be there. I think, right? Otherwise, these questions you are solving anytime, right? Yeah. Just- Okay, just a minute. Okay. Okay. Now tell me. You did the like I though scored 80, but now I see the actual marks are around 65. I don't know the exact result. Okay. Uh, okay. So the thing is, I didn't practice more. Okay. Satya, what you are saying? What happened to you? So exam hall, you said like you got like 80% and see, I think the silly mistakes have happened if I feel it correctly. Otherwise, you are able to answer it correctly right now, right? So the main reason is how you are doing the practice at home. That is the main part, I think. So whatever we are saying here, or whatever you are watching the recorded lectures, how you are doing your. So are you guys solving those or like whatever the theorems are there? Are you writing it by your own, trying to understand what is happening? How you are studying? Can anyone tell me? Like I wanted to just understand it. Or what do you think we should teach you, like how should we approach the when we take the sessions also, how should we approach those sessions? If you can tell us that also, that is fine. Anyone? No, you guys are very upset with the results.
Sir, but the results are not out no yet.
Not yet out, but I think all of you know, right, what are your marks. You have the answer key with you. You can actually match. And
Also, there is a site we can check the marks.
yeah, and I think it is official site, right?
I don't know,
Yeah,
but maybe.
I think it is there. So yeah, you can actually check.
Yes, yes. Sneha
Yeah,
shared that.
this is official site, I guess. It's like ITM site only. Fine. Okay, let us start. Okay, if you don't have any feedbacks, then we'll start with week 7, right?
So, sir, how
Ah,
should we? I mean, what is your advice? I mean,
yeah, so what I'm trying to say is, when you watch the lectures, okay, so okay, why I'm saying this, because let's say when we are teaching you, it's we also have to go through the lectures, right? First of all, we see the lectures, and then we'll we also studying along with you guys, right? Like whenever we see, okay, because of the multiple times we are actually teaching it some courses, we get better at it, let's say, right? Because same thing we are repeating it. Maybe it is not you don't have much time to repeat the same course or to understand it better, but you, whatever time you are having, how should you approach it is, as per my suggestion, it should be like, you, whenever you are watching lectures, watch it thoroughly from, like, in the first view. So whenever you watch it first time, you may not be able to grasp everything, right? Here and there you can actually lose it. You will have to again go through, maybe you can go through the lecture notes, right? So Arun, so when we talk about only this part, right, this part of the course, which is MLT. So in MLT, sir has actually written very nice notes, right? Whenever he was teaching it, like, it's proper manner, but the thing is, we'll have to understand each of the line, right? Something is hidden into that line, correct? So whenever we are going through a PCA, or maybe the kernel functions, you may not be able to understand it in the first glance. So you'll have to again watch those lectures, trying to think about it, like how much of the part you understand it well, right? So whenever you go through the lecture notes, where you are stucking, right? And after that, once you think that my understanding of this lecture is whatever the entire, okay, I'm when I'm talking about lectures, it is like you will have to go through entire week's content. So it may be 5 lectures or 6 lectures. So once you watch all 6 lectures, and then you try to see through all the lecture notes, once the understanding is clear, you if you think that my understanding is better now, then go through the practice assignment questions. Try to try to answer your questions by yourself. Like, you should have that confidence, right? Out of that
you mean the activity questions, right?
activity questions also, and the practice assignment questions also,
Okay,
practice, right? So for, because that is where you will understand your understanding of the lectures, right? Or that
right,
topic.
sir.
So just see that how many questions out of those 10 you will be able to answer. Let's say you answered 8 questions correctly, and let's try to see where these 2 questions you got wrong. Now you just again go back to those concepts where you got the answers wrong, right? Then only, see, once you should challenge yourself, right? Your understanding, that whether you will be able. So if I given you the chance, if I ask you, write down this algorithm for me, whether you will be able to do it, maybe with the little, help, right? Little help of the notes, right? If you are able to do that, right, I think that is the condition where you understood it well. Otherwise, it is tough. You have to see yourself, like, where you are standing, because all of the questions, if you see in the paper also, they are not like coming from anywhere else, right? They are like exactly same thing what is there in the course. See, you can do mistakes. Which questions you can do mistakes, which I feel is, maybe if you do some calculation mistakes, right? So for any type of questions, the student should do the, or may they can do the mistakes. But for MCQs, I don't think, right, you should be doing the mistakes, because out of the 4 you will have to uh, mark that answer rightly. You shouldn't do the mistake there. The calculation mistake we can understand, because it will happen to everyone, but the mistake shouldn't happen in the MCQs. And if you see that, out of the 40 marks paper, the MCQ and the NATs, they are evenly distributed, right? Almost evenly distributed. And it is not like every time you'll do the calculation mistake also, right? Let us see. Okay, we'll see what we can do, again, more of to understand it, right? So see, these notes, right, they are very important. So if you, let's say, if you feel any difficulty here, if you don't remember what sir has said, you just go back to that lecture, again watch it, watching the lectures 2 or 3 times, it is important. At least 2 times, not 3 times. It's not required, but 2 times at least you should go through it. You should ask yourself what points you understood well and what points you don't understand, right?
Yes, sir. Right.
Yeah. Okay. So shall we start with week 7 now?
Yes, sir.
And okay, okay, what, how you study? Okay, can you tell me what is your like, how do you generally go through? It's not like 2 days before the deadline you will start watching lectures. You'll do that, or and how
No,
you
no,
solve
no.
the grade
I
assignment?
was I was doing the same. I mean similar way.
Okay.
I watched the lecture, then I solved the activity questions. Then every after all the lectures,
Huh.
I attempt PA, and
Okay, so
then
before
GA.
the exam, before your final quiz one, let's say, have you solved some of the previous year questions?
Yes, sir. Yes, sir. So
Okay.
I don't think the questions are tough.
Maybe
I
then
mean
exam pressure.
in the hall, yeah, maybe
Uh,
there was some silly mistakes and calculation mistakes, and that's I mean that is the thing. I think. Otherwise, how can I be? So confident that I'll score more than 80%. That is a problem. I think.
I think the calculator is a bit difficult to not
Yeah.
user
One more
friendly.
thing, sir. The
Not
mouse
user
was
friendly.
clicking twice. I mean, in the exam hall. So I click once, that clicks twice in the screen.
But
So
you ask the person at the exam center, he'll replace your mouse.
yeah, I didn't do that. So that was
So the calculator given in the dashboard is actually not very user friendly. That's what my observation is.
Yes, sir, I
Maybe,
agree with Siddharth. It is at times it takes a lot of time to actually do simple things on that calculator. So that needs
and
an upgrade.
we
And
cannot
this,
we cannot input digits from the keyboard. That's the I mean if they input in add that functionality, I mean that will be helpful. Uh, Maybe we will punch the character, I mean the digits from the keyboard.
but actually that calculator is being in use since last so many years. Nobody has complained about that. So, but whenever the exam involves some calculations, then you have to go to that calculator, and somehow it is not very user friendly. That's what I found.
right, even the basic calculators available online are better than the one that we use in the exams. So that calculator needs a serious upgrade.
I didn't find any key for finding the square root. Actually, I tried to find it, but for finding
No,
square root,
Yeah, there
there
was
was one, but
SQRT,
uh,
that button was there.
but the way it has been placed, it makes it very complicated because
ECS
you
calculator, sir.
yeah,
Uh,
the
if you're
square root
searching,
key
sir,
is there actually.
yes, yes, sir, yes. Yes, here it is square root is there, but in the exam hall I saw it it was written SQRT. Yes. So you are not audible. I think you muted yourself.
am I audible?
Now you are, yes.
Yeah. So I think, see, this is the calculator. So there is a, like, how you do the, like, generally what you do is just you just press if I wanted to find the square root, I think our usual thing is like we do like this. We'll first of all place square root and then try to put in the numbers, right? But that's not the way it will work. Here we'll have to write the number first and then take a square root, right? Or maybe if I wanted
so
to do,
Yes, point
that's
0.5
what
to the power
you
point
guys
0.5 we can do.
that's what you the instructors have been telling since the foundation level,
hmm,
that whatever activity questions you do, you use the
yeah, this
calculator
one.
given in the dashboard.
Yeah. So by this time it should be very user. It should be user friendly, right?
Yes, but actually, in between all these exams,
Uh,
no calculation
no,
was required.
uh,
Here in this paper, some calculation was required. So that's where people got it wrong.
but still, see, what you can do is most of the calculation try to do by hand. Like for example, uh, the calculation for this question, let's say, right? Don't ask calculator to do like 4 into
Yes,
5
yes.
minus 1. You just,
That is
because
just calculating the determinant, so it's not very difficult.
so for this kind of calculation, if you are relying on the calculator, right, then it is tough, right? For this also, see, I can just see that you can see directly, like it is 3 plus 4 by like 7 by root 2, definitely, right?
So
7 by
7
root
by
2.
root 2. Yes, you just do
Only
7
the,
by root 2
yeah,
on the
do
calculator.
7 by root 2 like this, right? And maybe you can do mistake once, but you may not. So let's say if I do like this, like 7 by, let's say, root 2, now it is wrong, right? You can do like 7 by, okay, okay, so maybe the second or third attempt will be able to, but it will not take much time, correct? So but if you are relying to do this calculation, suppose if you wanted to do like this, the complex calculation, like for example, if I wanted to do uh, like if I use root 2 by 2, suppose root, if you are doing this calculation like this, root 2 divided by 2 into what is it, 3
7, 7, 7.
3, or let's say if I do this calculation, then you will do
Get
more,
it
like,
wrong, get it
yeah,
wrong.
right? So you don't do this, at least
Simplify
whatever
it
level,
and then
yeah,
find the answer.
yeah,
Simplify it first.
then you will not be able to. So for this calculation also, let's say this calculation, 1 minus p to the power something is there, right? This finding out the maximum likelihood estimate of p. You don't have to do
Then and and then if you round off twice in the middle of the calculation, then the answer will be different also.
so don't do that. Do as much, like whatever simplification you are doing, right? You do as much as possible humanly, right? Or like you can do.
Yes, sir.
If you do everything on the calculator and if you say that it is not giving the answer, then it is tough. Let's say this, for this question it is tough, I can understand, because here
So
it's
here
not like,
also, if you do the simplification,
yeah,
then the answer becomes very
I
easy.
think it is
It is actually
0.5 e
1
to the
by 1
power
plus
something
e,
like,
1 by 1 plus e raised to minus 2.
I think 1
1
by,
by 1 plus
uh,
e to the power minus 2. Yes, this is the
so
answer.
so you just have to do like do this first, write down the answer, maybe right here some whatever the answer is coming, let's say point 1 point something, right? 1.007 something, and then do separate calculation if you want to do. But so if don't do like 1 by this, right, in the calculator, because you don't know what it is giving. So try to write the answer for this, write down on your paper, and then do separate calculations. Then also you will not be able to do a wrong thing. You can simplify it up to this part, actually, right?
Yes, sir.
This, for this also you don't have to do much. For this calculation, I don't know. Covariance matrix
No,
you can
no, no
do
calculation is required here, sir.
here also, right? I
Yes,
think the
yes.
last one
Yes,
maybe.
18.43 REIT is required, yes. Because
I
you have
think
to
so.
center it and all that you have
Uh,
to do. So in
Centering
18,
also, I don't think. I think until covariance part, right? Covariance matrix part, you don't have to do anything.
yes, yes.
Only when you find the eigenvalues of this matrix, covariance matrix, then I think like A equal to something, that quadratic equation comes in, I guess. It is a 2 cross, yeah. So this will be your, yeah, 2 cross 2 matrix will be there, right? And then 2 cross 2 matrix, you will have only two eigenvalues will get, I think, right? Yeah, I think, see, what I am trying to say is, like, don't rely on the calculator, do your calculations in the paper itself.
First simplify it and then
Yeah,
just find the,
yeah.
yes.
Okay, have you guys gone through week 7 content? It's is very easy content, okay? It's like it's not much difficult here, but have you watched the lectures? No.
Not yet, sir.
Okay.
Yes, sir. Few lectures I've seen.
3. Okay. Okay. uh, what should we do then? Like, you don't have much time, let me go through it then one by one. Let's try to understand it, okay? This is the completely new topic for us. This is a supervised learning of the binary classification, right? Till now, what we have learned is unsupervised algorithms. Which algorithms we have learned is um, PCA. Its version, another version of it is kernel PCA. Then we learned about, I think, clustering, right? For clustering, we used two different approaches, which is one is I think K-means clustering, and another is EMM algorithm, right? Sorry, EMM expectation EM algorithm possibly, right? Which is a part of Gaussian mixture model, right? So that we have studied, and then after that we go into supervised learning part where we learned about linear regression, and in linear regression we saw another version of it is as kernel regression, right? For when you wanted to deal with the uh, higher dimensional data, right? Then I think in week 6 there were two variants of linear regression. One is I think ridge regression, and another is lasso. But this topic is now again the completely different topic than the previous topics whatever we have learned. So here our goal is to what? So this is not multi-class classification, it's binary classification. When I say binary classification, what does that mean? There will always be two classes. So here our goal is to, and again, if it is a supervised learning algorithm, what does that mean?
Labels are given.
You will have the labels during your training data, right? So during your training, you have labels available for your uh, input features, right? So and these input features can be in d dimensions. What will be the nature of these labels?
Either 0 or 1,
One
just
or minus one, or it will be a
only two,
set of two
only
values,
two values, only two
right?
values.
Yeah, it will be a set of two values. They might be 0 1 or minus 1 plus 1 or any other thing, but only two values will be there. So what was our goal in linear regression? So I think it's a supervised learning algorithm. So it is a similar algorithm that as that of the linear regression. So what was the setup in linear regression case? We had this data, right? And we have corresponding labels there also. And what was the dimension of each exercise here? They were, let's say, d dimensions, and each of y will belong to R. And the goal was to find a model that is H such that we will be able to input the d-dimensional features and output what? A real value, right? And then how we said that this model will be a good model when the, or what was the criteria for it? The criteria was mean squared error, right? Mean squared error between the, so this will be
Label
your,
and its prediction.
yeah, this is a predicted label, right? A predicted output, and this was the actual label. So your prediction will be let's say hi yi minus, suppose let's say hi, right? And you will take a sum of this from 1 to n. So you have n examples here, you can see here n examples, and each example is of d dimension, and you will take the squared sum of error, and that is your, it is called as a mean squared error. So we try to minimize this quantity. So whichever model h will gives me the minimum squared error, that will be a good model. That's what we have said, right? And then we have seen the lot of variation to it. That was also your supervised learning model because of it is having the labels associated with that. Similarly, classification or binary classification is also a supervised learning algorithm. That means during our training, we always have, like, we have availability of the labels. corresponding to each of the training example. So our data was like this. Here also it is x1, x2, 2, let's say xn. So, and what is the nature of this data? Or each of xi, each of the training example will have d features, right? So that means d different values will be there. You can actually make it as a vector, and it will also have the corresponding labels. The only difference between the regression and the classification is that the nature of labels. So here the labels will be the set of values, either 0, 1 or minus 1, 1. So we can say that it is a positive class or negative class or any other class also. Let's say human face or non-human face, like that. So what should be your goal here? To find a model such that it will input this x1, x2 or xn, right? Like all of this data which is in d dimension, and output what?
Either 0 or 1.
1, right? So that should be the goal. So naturally what comes in our mind is that what we have done for the regression part, what we have done, whatever the prediction is there and whatever the actual value is there, we saw how much deviation it is there, like each of, like how my model is able to predict. So we have seen the deviation, or what does that mean? The error between the prediction and the actual output. Can we do the same here? If I do the same, what does that mean? We'll check whether this. But how, if I take the squared error, will this work here in the classification problem? If I take the squared error, what should be the error? So what do you think like the error should look like? Suppose I have the data set. Let's say you have features f1, f2, f3.
Yes, it will work, I think, sir.
Okay, let's try to understand. So let's say these are the examples. Some values will be there. Okay, some what values? So let's say a1, a2, a3. So b1, b2, b3, and you have the corresponding labels. Suppose you have the labels as 0, 1 or something like that. What will be the prediction here? So you, okay, let's say you predicted, either you can predict 0 or 1, right? For every prediction also, will it have different values than 0 and 1?
No, no, it will have
It,
0 and 1 only.
so 0 and 1 we wanted actually, right? If I use the linear regression model, suppose if I take the uh, like hypothesis or our model as the linear regression model, what it will throw, it can actually give me values between 0 and 1, right? So
Is
if I
real
use
number.
that also, will that work? Or what is that required for us? What we actually wanted here, either it
0
it
or
should
1.
give 0 or it should give 1, right? If these both the labels are same, then we say that okay, this is the correct prediction. And if these labels are not same, then we say that this is not giving me the correct predictions. That is the thing here, right? So what our model should do, the mathematical model should do, if I input all these features, right, or all these vectors here, my model should be able to predict only the values between 0 and 1, correct? And how will we say that it's a good model? If the
Y and
model
Y
will be able to
tracer
predict,
matching.
yeah, if that means if I have 100 examples, and for 100 examples if I say that one model is able to predict for 90 correct, so will it be like based on 0 or 1, or it will be based on if both of the actual and the predicted is having the same values?
Both.
Actual and predicted having the same
Same
value.
values, right? So that means when I say it is classifying incorrectly, when these values, so how many correct classifications are here? This is
Only two,
this is the
two.
correct, this is correct, and uh, this is
Second is not.
incorrect, and this is correct, right? So second is not correct, correct? So here we have, out of the three examples, if this model is able to predict, so what is the error here?
1
Can
by
I say
3.
the one? One. It is able to predict it. So one wrong, right? One wrong and two
Out of
correct
3.
out of the three. So average error can be 1 by 3, right? And this error is called as a misclassification error. So in this classification problem or binary classification problem, we are not worried about because we don't have to worry about the continuous values of the output, right? Here it's only either I can classify it or my model should also be able to classify it into two values only. So how many correct predictions it is doing, that matters to me more than the. So if some algorithm is able to predict 90 correct out of 100, and one is able to predict 80 correct out of 100, which model should I choose?
90.
90.
90. So that means how many misclassification is doing there, that model?
10.
First model is 10 and
Uh,
another model is giving me
20.
20 misclassifications. So what is the average here? 10 by 20
15.
and no, no
10 by
separately,
Oh,
100. 10 by
10 by
100.
100 and 20 by
yes.
100, right? Separately.
Mm.
Fine, right? So here how we define loss here? How many misclassifications happening, right? Correct.
Sir, I didn't get this symbol. What is this I?
It is not I, this is one. So it is called indicator. If you have gone through our MLF lectures, right? So I think in the
Yeah,
first
in that
week,
first.
first
Yeah,
lecture, it is mentioned that indicator variable will take values 1 or 0, right?
mm,
So when it will take 1, when z is true, and otherwise it's not. So what does that mean? So if this is my, so what is z here? H of xi is not equal to yi. So whatever the prediction it is having, if it is not equal to uh, if it is not equal to this, then it will say 1, right? Correct. Okay, so let us try to understand through example here. So suppose this, I will take the same example. These are the features. Let's say this is my first example, right? Let's say I'll take the values. Let's say 1, 2, 3, maybe 2, 3, 5, 3, 3, 5, 2, 4, 5, something like that. And you have the actual label as, let's say, 0, 0, 0, 1. Okay. And so each of xi is having how many dimensions data is there?
3.
3, right? So each vector can be seen as 3 dimensional data. Is that correct? And each yi here belongs to the set
0,
0, 1. Now let us say h of xi is giving me, let's say, 1, 0, 0, let's say 1. Okay. So the loss or error here, and this error is called as a misclassification error, is equal to summation of I equal to 1 to n. So, and what is equal to this? So this is the generic loss, right? It's like indicator variable when h of xi is not equal to yi. Okay, and it will indicate 1 when.
They are not equal.
So indicator of z equal to 1 if z is true. What is z here in this case?
HXI not equal
This
to
one.
Y.
Yeah, this argument, right? And if z is or otherwise. Fine. So let us try to understand for this example. Uh, so how many, one by how many examples I am having?
4.
4, right? And I will have to sum of across all these 4 examples. So what will happen for first example? So
1.
my z is equal to here h of xi not equal to yi, right? So for first example, what happens?
1. Z will be 1.
Why? Because is yi equal to 1? No.
No.
So that means it will say true, right? Is this argument true?
Yes, sir.
H of xi is not equal to yi, right? What about the second case? It's false.
False.
Here it is false, and here it is false.
False.
All of you understand this part? Now, indicator variable for so indicator for first example is true, right? So what is the indicator variable here for true? When z is true, then
1.
1 plus for the second will be
0.
0 plus 0 plus 0, and that is equal to 1 by 4. And in other words, what we can say that how many misclassification my model has done. So how many misclassification has done?
1.
1. So one misclassification out of the 4, and that is the same thing it is written here. But in a mathematical way, we'll have to write using the indicator variable. If I just wanted to understand naturally, it should be like the number of misclassifications happened, or I can say, let's say, average number of misclassification happened uh, or done by the model. Understand? I hope it is clear.
Yes, sir.
If I say that it is like this, then
3 by 4.
what will change? So here it will give me 0, because first argument, if h of xi is equal to yi, no. So 0 plus 1 plus 1 plus 1, so it will become 3 by 4, right? So this z is actually the argument inside that, and if the argument says true, then the indicator variable will give 1, and if the argument is false, then it will give 0. I hope that is understandable now. Correct? So what we did in linear regression case, what we used to do, we used to minimize this error, right? Mean squared error, basically. We used to do that, but doing the same thing here, right? Minimizing this uh, error will be hard, right? So it is a hard problem to solve. So we'll have to look for other algorithms to solve this. We cannot just do this optimization problem for this part. So what we can do is, maybe we'll try to see. So what actually okay, this is also one of the parts, like why can we use the linear regression to solve the classification problem? It is possible, but the problem here is what? If your data is uh, if your data is okay, let us okay, sensitive to the location of data points, like what I have you gone through these lectures? If not, then maybe I'll draw it again. Otherwise, okay. So if I wanted, what does your linear regression does? How it works generally? Okay, maybe I'll use the same diagram. Possibly how
So
it is
try to find a W which minimizes the
error,
mean.
right? So that means you are trying to find out the best fit line there, right? Which
Yes.
fits the data set. But here the data set might be like this, right? Suppose this is one class. Let's say this is a positive class and there is a negative class. In the regression, the data set will not be spread like this, right? Okay, what will be the decision boundary here? So if I try to fit the linear regression here, what do you think, which line it will give me the
45-degree line, sir.
right? So possibly this might be a good line. Can I say that as per linear regression, correct? And what we can say that if I wanted to classify this, what we can do is, maybe we'll see the perpendicular boundary, right, to
Yes,
this,
sir.
correct? So this will be my decision boundary. Is that correct? So we can say that if this is my W1, so whichever the perpendicular line is there, or W, right, like line which is perpendicular line to W will be my decision boundary. Is that correct? And this is
Yes.
giving me the correct classification, as you can see. But suppose your data set, like if you have some more points, right, somewhere here,
So the classification boundary is the boundary
which is perpendicular to
which
this,
is perpendicular to W,
Yeah,
and which makes in short, it is the product between that line and W is 0.
0. Yes, yes. That should be.
Yes,
You can understand it, right? Is it
yes,
correct?
yes, yes, sir.
Otherwise, we cannot say this is the line because it is not perfect. We wanted a classification between the two classes, and if you see that if the line fits through the data, what you can do is now I just take the perpendicular line, and now that will
And
perfectly
the points lying to the left of the line will be
will be,
minus.
yeah, that is like simple thing, right? Once you found out that line, you can actually find say that the threshold will be there, like whichever points lie on this side of the line, right side of the line, they will be positive, maybe one class, positive class or negative class, and on the other side it will be, it's like very straightforward. But what happens to this approach, it for now it looks like it's a good approach, right? Because if you see this data, it looks like a good approach. But suppose if you have some more data points here, so you know that these are also the data set, data points from the, let's say this is one class, right? Let's say this is class, positive class. Let's say this is negative class. Uh, sure, what is, let's say with your understanding, you know these are the data points. But what happens to linear regression now? If I try to form a like line between this
The
data points
W
now,
changes, I think. The W changes now.
okay, what do you think should be a good line here now if
It
I
should
have this
go
kind of data?
towards 0. The from 45, it should go towards 0.
Can I
Yes.
say that maybe this will be like this somewhat? It will try to fit every data, so possibly it will tilt somewhere like this,
It will go from 45 to 0. Yes, somehow between 0
right?
and
Like
40.
yeah, between this, is that like fair assumption, right? And what will happen to our decision boundary now? We said that it should be perpendicular, so where it will be my decision boundary, it will also shift, right? Right. So likewise, if you have, so suppose if I have some data here, right? Now it will try to because linear regression will try to fit all the data points, right? It will try to tilt it like that, but it is not desirable for us, right? Because these points here, are they the points from the negative class? Yes, right?
Yes, sir.
So now if because of this, if it is trying to tilt it here, what happens here?
They will
The,
be classified as positive now.
yeah, now the errors, like the error might be more, right? So that's why this linear regression is not the suitable algorithm for this classification problem, right? Because it is sensitive to the data points, right? It is, we know that it is very sensitive to the data point, because that is how your uh, algorithm works. But that is not suitable, so we need to have some other kind of algorithms, and whichever the first algorithm comes to your mind is, let's say, this one, k nearest neighbor, which is the simplest one. What does it say? uh, Whenever any test point, it will, okay, so during training, what is given to us? So suppose you have a training, you have these data points, this is, let's say, positive class. We know that, right? We know that these points belongs to positive class, is that correct? Because that is what the supervised learning algorithm is. Suppose these are the data points. So the best algorithm might be, what do you think is, maybe you have uh, a data point here, suppose, right? This is a test data point, let's say x6, and if I use the k nearest neighbor algorithm, have you seen k nearest neighbor before also?
K
No,
means
sir.
algorithm
I
maybe.
think, okay, k means you have seen, right? So k nearest neighbor, so this is a new algorithm which is k nearest neighbor. What does that mean? uh, you see the k is here, the number of neighbor points. So what do you think, okay, by looking at this point, what do you think, what is your understanding, the intuition about it, which which class it belongs to,
Positive.
right?
Red
So
line,
let's say this is
red
positive,
point.
and yeah, let's say this is negative. What do you think, and how you come to that conclusion that whether it is coming from positive or negative class?
It's closer to the red
Yes.
ones.
And how, in mathematically, how we decide whether this point is closer to any
Me,
other point?
distance,
Yeah,
square
so
distance.
you will do Euclidean distance, right? Is that correct?
Yes.
So now the yeah, it's like it's very intuitively it looks good, right? So whatever the point comes in, we'll see that which class it is closer to, and to understand mathematically it should be the Euclidean distance, right, which is closer to those points. So now I can say that, oh, but here k means here k denotes the number of nearest neighbors. So I have a choice. How many choices I can have? If I have n data points in our data set, training data set, how many k's I can choose?
N.
I can choose one, I can choose two, I can choose three, I can choose. So, so now the k is a hyperparameter here, right? We'll have to decide beforehand which k I should choose. Correct?
Yes, sir.
Right. So let's say if I take k equal to 1. So here, what does that mean? It will check the, so what do you feel that it will check for uh, all the data points, right? It will check for this, it will check for this, it will check for that, and it, how it will based. So what is your decision based on here? The decision is based on
Closest distance.
closest one point, right? When k equals to 1. So generally this is denoted as this. Why it is, the prediction is dependent on majority of this, right? Correct. So okay, I'll try to maybe explain it a bit. If you have k equal to 3, what does this will do? You'll have to check the distances of uh, this one, let's say this one and this one, right? It will take, but for that for how many distances you will have to calculate here?
N. N.
N, right?
Yes,
So
sir.
even if I have k equals to 1, or even if I have k equals to 2, or even if I have k equals to n.
If you don't have the graph, then you'll have to calculate N distances. But if you have the
Yeah,
graph,
no, no,
then you can
graph and
calculate.
all, like visually you can say, but uh, this model will have to tell us to the computer, right? So for computer, how this algorithm will work? It will check for
N
all n
distance.
distances, and when I say k equals to 3, what it will do? It will see the minimum
Three closest
distances,
points.
yeah, minimum distances among these n data points, right? And now it will check what? Let us say these are the minimum distances. Okay, what does it do now? The prediction will be, y test prediction will be,
Majority of the. So
so
all these 3 points are
so what
positive.
are the, okay, it will be the majority of these 3 points. So what is, let's say this is 1 and this is class 0. So what is here? So for this 3 it will be 1 1 1, right? So the majority will be 1, so it will classify as 1. In other cases, let's say you have a data point here, possibly suppose your class is like this. Okay, so now I will try to understand this part.
Suppose, sir, K is even, and you have even number of equal number of zeros and ones.
Then
Then
in
what
that
will
case, it you can either classify it as 1 or it can either classify as 0. It doesn't matter, right?
okay.
Because then that point will be on the decision boundary. But the point here is, let's say k equal, it doesn't matter k equals to even or odd, but uh, the because it will decide based on what? The resistance, minimum distances, right, or majority of it. So for now, let's say if I'm saying that, let's say k equals to 3 and these are the 3 closest point, right? So what it will be the majority of, let's say 0 1 and 1, so it will predict as
One.
1,
One.
right? Like that. What happens if k equals to 1 is there?
Then the closest point, whatever
So
the
let's
closest
say,
point is.
this is the closest point, it will just mark it as positive,
One.
right? But suppose your test point was here, Okay, test point was here, and now I'm just telling that uh, just saying that, let's say this was the uh, okay. So okay, sorry. What I was saying is, let's say k equals to 1, and okay, b, your test point is somewhere here, okay, and your data set is like this, right? And you can see that what, which, let's say for k equals to 1, this is the minimum distance, for example, right? This is the minimum distance, uh, and the second minimum was this, and third minimum was this, suppose, for argument's sake. What do you think k equals to 1 will be? So now, is it giving me the correct choice, or it is not giving me the correct choice?
It will still give red, right?
It will still give red. And what do you think, will that be a good thing, or will that be a bad thing? It's bad, right?
Yes, sir.
Correct, because you see, if it was k equal to 3, it might have classified as zero class or negative class. Is that correct? Because the majority of these three will be these two. So these two are like, there is a more chance that this point should have been into this cluster. Is that correct?
Yes, sir.
So that is called as underfitting, right? So like maybe we'll have to go for the higher number of k nearest neighbors. What happens if I have k equals to n?
And the maximum number of points will be there that will be given. Suppose the
So
more
if you're,
number of
yeah,
points are zero, then it will be
so
zero.
yeah, in your training data, suppose you have 600 plus 1 or positive class, and let's say 400 data points are with negative class. If I use k equal to n, that means in this case k equal to 100, what happens here for my
All the
test?
test points will be given plus one.
So all whatever comes in, it will be given as plus one. So that means it is going to overfit, right? So it actually, but actually, okay, overfitting and underfitting will comes later. But let's say that is a problem occurs there, right? For this, if I have a balanced data set, then also it will get confused, right? What will I do? So are we learning anything here in this algorithm?
We have to
Learning
find
means,
for each test point. You have to find all the distances.
yeah, always
So,
whenever I have new test point, I have to find out all the distances.
so
The
new learning.
We are not learning anything, right? Because what happens in learning? So let's say in the supervised in the linear regression case, what was the learning? We learned that line, and then
You
have you
find the
worried?
W and then you use that W for a test data.
Yeah, so we never then after once you learned that W, or that the best fit line, have you worried about the training data later on?
No, no, no.
No, right? So we throw it away, and whatever the next points coming in, right? Whatever the X test will be coming in, we'll be able to predict it. But is that the case with this algorithm?
You
No.
have to find
Whenever you
all
have a new test data point, you always have to calculate all the
the
distances,
distances.
right? And that is the problem with this algorithm, right? So that means it is not a very good algorithm, right? So there are a couple of points here. I think what should be
Sir,
yeah.
I had a call, sir, in between. You can just summarize it for me because I'm not able to follow what you're telling beyond. I just lost in between.
Okay, until where you were there with me?
Sir, this entire algorithm, KNN, when you started.
Okay. Okay. So okay. So in summary is like, let's try to, maybe I'll just give a gist of it again. What is k nearest neighbors? We are finding out the nearest neighbor to the test data point. Okay. So you have some data points here, maybe because we are actually dealing with the binary classification, so we will always talk about the two classes. Suppose you have this is let's say positive class, the red one, and let's say this is a negative class. Okay. In k nearest neighbor, what you do, the algorithm is, it's a very simple algorithm. Whenever any test point comes in, right? So this is, let's say, x test. Okay, how you decide whether it is from the positive class or negative class? So what do you think? What is your intuition about this point? Which class
Based
it
on the
should be?
distance. Yeah, it should go in the positive side.
Positive class. And how you decide it?
Based on
Mathematically, you will
distance.
check the distances from this point. And so what you have to do here, you'll have to calculate the distances from every data point, right? Every other data point in this data
Yes.
set. And then you will feel, when I say k equal to 1, so what do you do then? We'll check that which one data point is closest to this test data point, right? Right. So in this case, it might say that this is the closest one and I'll go for positive class, right? But is this a good strategy? Suppose you have a data point possibly, so here, okay, uh, what do you think which class it should belong to now? Let's say if I use k equal to 1, what is the answer here? Okay, I'll tell you. Let's say this is the minimum distance. Okay, this is the minimum distance. This is the second minimum distance. This is the third minimum distance. Okay, if I use k equal to 1, it will, let's say, it will calculate the distances for all the data points, but it will choose which one, which class?
The positive.
Positive side, right? Let's say you have k equal to 3. What will happen now? So k equal to 3 means it will take this 3, right? Why? Because these are the three nearest thing, and the prediction happens in this case as, so y is prediction, or y prediction of this, I'll say y is predict is equal to majority of these three. So let's say this is plus class 0 0. So what it will predict now, when k equal to
0.
3 is there, it will predict as 0. So that means I think it is desirable, right? So if you, how you can increase k, like you can have k 4 5, it is based on your choice, and hence this k here is a hyperparameter, right? This is not learned from any algorithm, right? So when in case of the linear regression, what is the, so we learned this thing, right? Wx plus c, or maybe b, right? So this w is a hyperparameter or a parameter, right?
Yes, sir.
Because we actually, so parameter is that part of the algorithm where or that thing which we have learned.
Yes.
Yeah, we have learned through or through algorithm, or through our understanding, like through the data, right? We have learned it through the data, using any algorithm. Here, are we learning this k? No,
No.
we actually are saying that we will have to see whether which is the better one. How to say that which k is better? You can have k equal to 1 first, right? And then you see the how many misclassification error it does, right? Then you will go for k equal to 2, then you will see for errors. K equal to 3, you'll see for errors, and you will plot all of this, and which will you choose? Whichever gives me the minimum
Minimum.
error. So how for how many we can go? How many k nearest neighbor we can choose if you have n data points in your data set?
Maximum n.
The maximum n. So what happens with n now? So suppose you have n data points. What did always, so okay, and let's say your data set is like that. You have 60. This is the training data. Okay, you have 60 data points which are positively labeled and 40 negative labeled. And if you use k equal to 100 here, for any x test, the new data test point, what will be the prediction? What do you think? It will always be positive class,
Yeah.
right? Why? Because when you have k equal to 100, it will the majority of that will be always 60, right?
Yes.
And so 60 is always majority. So even whatever, let's say if the data point is here also, right, the test point, if it is here, what it will predict for this k equal to 100 or k equal to n?
Yeah, it was
It
still
will
pretty positive.
positive, because it will calculate all the distances and it will take majority of it. So this is not, so there is a method called elbow method, right? What does it do? It does the same thing, like it will check for the how many misclassification errors it is happening, and it will have to see that so it will, like the graph will be like this, right? So sometimes like this, so we'll choose the k which is here at the elbow. Okay.
So for all the hyperparameters, value of k, which is
Yeah,
somewhere
it
between the minimum and maximum, is
yeah,
used.
hyperparameter, I think, have you heard of the term of hyperparameter tuning? I think it
Yes,
is very
in
popular
that
term,
k
right?
means it was there, na? K means.
K means, yeah. So wherever the hyperparameter comes in, right? How you fix that hyperparameter? By trial and error, right?
Okay.
You'll
And
have
it
to
is
see
always
that,
always the value is between the minimum and the maximum. It is can be never the
yeah,
minimum or maximum.
yeah, because it will always have its problems, right? Its own problems. So correct. So the hyperparameters will be different for different algorithms, but it is here k. So this will be the decision boundaries, right? When k equals to 1, what happens? It will try to get like very closer boundaries. If k equals to n, what will happen? It doesn't give me any boundary, right? It will always predict one thing based on the data. So it is having inherent issues, right, with it. Fine. Okay. Any issues here?
No, sir. Thank you, sir.
Right. So this is the k-means algorithm. Sorry, k nearest neighbor algorithm. Uh, do you think is it a good algorithm for our case classification?
No, because it is not learning anything. It is
Right.
not.
We are not learning anything because every time any new test point will come in. So now what, for every test point we'll have to calculate the distances from each of the data point, right? That is
Yes.
not desirable. Then we cannot throw away the data once it is learned, right? Which was the case previously. Whenever whatever algorithm we have learned till now, we used to learn it and then we'll use to throw the training data away. We don't use it again and again for any predictions. But here for every prediction, we'll have to use that training data. We cannot throw it away. So that is the problem with k nearest neighbor. So we'll have to find out any other good algorithm here, right? So then there is another algorithm which is called as a decision tree algorithm. Okay, decision tree. Okay. Uh, okay. So the setup is same. Input is your data set with kind of labels. So each of the data will have the labels, and the labels are of kind of uh, a set of values, right? A set of two values. Here, okay, you're here, right? So yeah. What you do in this decision tree algorithm is that whatever the test point comes in, we'll ask some questions to it, and we'll take its answer as yes or no. Fine. So you can see here, this is a decision. This is one of the decision trees, the sample decision tree. What happens is whatever the question comes in, we'll ask it a question, and then we'll divide the data set into two. If the answer to that question is yes, then you will we take all those points into one side and another into another. So I'll give you an example, maybe a numerical example to understand it better. Suppose you have a data set like this. I will take only one uh, uh, value, right? So let us say 150 and the label is 0, 155 label is 0, 140 label is 0, 160 label is 1, 165 label is 1, 155 label is, let's say, 0. Okay, this is a simple data set. Uh, or uh, or okay, I'll just give some other, maybe 170. I'll take the 170 and label is 0. Fine. Is this okay?
Yes, sir.
This is the data set. What you do in decision tree is you'll ask the question. So suppose the first question is, suppose I say question is, if x1 is greater than or equal to 160 or 150, suppose, right? If it will have two answers, yes and no. If it is having, if it is yes, then how many data points will lie onto this side? What will be the data set? Initially, what was the data set? It will be x1, y1. Okay, this is x. Sorry, this is x. Y. This will be x1. This is x2. This is x3, x4, x5, x6. How does this data set looks like here? Initially, it was x1, y1, x2, y2, x3, y3, x4, y4, and x5, y5, and x6, y6. Is that correct?
Yes, sir.
Now, when I ask this question, x1 is greater than 150, or let's say x is greater than 150, in this case, how many data points will lie this side now? Possibly
Five.
x1, y1,
One.
x2,
X2, right? X4.
sorry, not x1, y1 here. X1 is greater than or equal to 150,
Equal
right?
to, sir. Yes, sir. So it will lie, right?
X1,
Okay.
X2,
X1 will
X4.
lie there.
Maybe okay. Maybe this is not a good question. Okay, okay. We'll talk about the quality of question, but yeah, for understanding purpose, it should be little bit higher. Let's say I'll say that 160. Sorry. Okay, now tell me. What
X4, X5, X6.
x4, y4, then x5, y5, and x6, y6. Is that correct?
Yes, sir.
Okay. And this side
X1, Y1,
x1, y1, x2,
X2,
y2, and x3,
X3,
y3, right? So now this is divided into, let's say, three data points goes into this side and three data set 3 points goes into that side. What happens? Either we can now say that, okay, uh, what let's say I'll ask another question, which is, let's say x is now uh, greater than, let's say, greater than or equal to 170. Fine. Then here at this question, I will have two more answers, right? One is yes and another is no. Fine. And now I say that if it is yes, then I'll label it as 0, and if it is no, I'll label it as 1. Okay, the final data set, this side it will be x6, y6, right? Here
X4, Y4,
x4, y4, and
X5, Y5, X5, Y5.
x5, y5, right? And here, let's say I have just stopped here, and I have I say that if it is answer no, then I will not do further anything, and I'll just say that it will have or maybe if you can actually ask the question, what question you will ask. Maybe here you may ask that if it is now, it's already 160, right? It's greater than 160. Shall I ask x is less than or equal to 160? Less than 160? Not required, right? When I say no,
All are less than 160.
right? So yeah, all are less than 160. So I should ask some other question. Possibly I'll ask x is let's less than, let's say, 140. Fine. Less than or not less than, I'll just say less than 140, and I'll have two yes and no. If it is yes, I'll say 1, and if it is no, then I'll say 0. So all three data points will lie this side, right?
Yes, sir.
So now will I be able to classify it properly? Is
Yes,
that
sir.
yes? Right? This is like classified 0, this is classified as 1, and all three other data points I was able to classify properly in 3. So what is the importance here? What do you think? What was the important things we have done here? Asking the right set of questions,
Yes, sir.
right? So that means quality of question is important. What is another thing? This is called a decision tree. So this is the, let's say, this is the depth of decision tree. Okay, which one? This one, right? These nodes are called as the leaf nodes. So here we have got the correct answer only like within how many questions we have asked? Only 3 questions we have asked, and we got the proper answer. But here, why we were able to do that? Because we had only one input variable, right? If you have like many more input variables, in that case we might have to ask, like, let's say 1,000 questions, right, to find out the proper boundary, right, or find out the proper classification. But is it then useful to find out that many uh, uh, boundaries? That will be a question, right? So these are the most basic uh, things we have seen here, right? One is what, the quality of question which we are asking, and let's say how much will be the depth of the decision tree. Is that correct?
Yes, sir.
I hope it is fine for all of you. uh, right, so whenever the test point comes in, we'll ask that question and it will go through the tree, and it will finally, wherever it will reach, it will be prediction or leaf node will be there. Right, so this was the case. We need to find out the measure of impurity for a set of labels. So this is one of the key concept here to so this is the key concept for, let's say, to ask what is the quality of question also, right? So this is the important part of it. What it is called, entropy of the. So I'll discuss about the entropy in a bit. Let us see how many things are there here. Okay. Yeah, I think that is okay. I'll just give me 5 minutes. I'll be coming back after having water. We'll finish it in, like, let's say 15 minutes after this. Okay. Yeah. Just give me 5 minutes.
Bro.
Okay. Uh, Hello. Okay. So first of all, try to understand what is impurity here. or we'll decide about what is the entropy. Suppose okay, this problem will be very easy. When it will be easier, what do you think? How the data should be like? If I have all the labels as one, uh, will this be a problem? This problem will be very easier for me, right? Then I shouldn't have to worry uh, about this data set. Is that correct?
Yes, sir. Or even zero, if it is zero,
Yeah,
then
all
okay.
zeros or all ones. In that case, I don't have to worry about um, classification itself, right? So the data set is called the pure data set when you have when you have all the labels as the same labels, right? And it is called as the impure data set, or we can say that the data set contains impurity when it is not having the, or when it is having the imbalance, or not imbalance, I can say that the different kind of uh, labels, right? So that is the, that is called the impurity. And there is a concept from which is called as entropy. So entropy gives me the, generally entropy is kind of a randomness in a in any kind of nature, right? So basically it uses, like in mechanical engineering, if you see thermodynamics, right? If you learned in physics also, the entropy concept is there. Here we are using the same concept, but in a different manner. What does it says is, um, if you have all the pure labels, that means if your data set contains all ones, what will be the entropy then? Suppose entropy, you can call it, think it as a randomness. Okay, so if you have all the labels as one, do you think that there will be any randomness here?
No, no,
No. If you have all the labels zero, do you think that any entropy will be there?
no.
No. That means there is no randomness. We are perfectly sure that uh, if all the labels are one, then any test point will come in will have directly the label
One.
as one. If you have all the labels as zero in a data set, training data set, we know that whenever the any text point will come in, we can directly assign it as a zero. We don't have to worry about it. But let us say if you have 70 or 75% of one, right? So let's say you have 100 data points, and in 100 data points you have 75 labeled as 1 and 25 labeled as 0. Do you have the impurity there? Yes, right? Because
Yes,
not all the data sets are pure,
same.
right? So this whatever the function is you are able to see, this is the entropy function. So it is a graph of entropy function. So generally for normal distribution, what is a graph for normal distribution?
Bell-shaped curve.
It's a bell shaped curve, right? So usually it will be seen at like this, right? So that is a distribution there. Similarly for entropy, the distribution is like this. Fine. And on its x-axis, what is it there? Any value between 0
Zero
and
and
1. So this value is actually called as p, and that is a fraction of ones in a data set. What does that mean? How many
number
ones
of
are there?
ones. Number of ones divided by the total one.
Yeah,
Total number.
total number of. So why we are actually choosing one? We can actually choose zero also. That's not a
Yes.
problem, right? It will be the same thing. Uh, and because it's a symmetric, right? It's symmetric about zero point 0.5 or half, right? And what is its on y-axis?
So
It is
for p equal to 1 by 4,
hmm,
the entropy will be same
same
as
as that
that
of p equal
p
to
equal
1.
to 3 by 4.
Yes, because it's symmetric,
Yes,
and
yes.
it's called entropy of p, right? So, and we'll see how we can actually, whatever example I have given, right? We'll try to use that example, or try to utilize this there. Okay, let us see this entropy of these labels. That means entropy of p will be equal to, so generally it is entropy of p equal to, it is minus p, or what is it, minus, I don't know, I don't know why it is taken minus, but okay, fine. P log
Because
P.
it comes out to be negative quantity, sir. This P log P plus 1 minus P log 1 minus P.
Yeah, because logarithms are for fractions,
Because
right?
the
Because we are actually using the fractions. So
fractions here.
P is like fraction. So log of any fraction is actually negative value.
Negative. Yes,
That's
sir.
why to make it positive, right? Fine. Okay. Uh, yeah. So this is the formula for entropy. So how we can use this formula for our case, that we'll have to look in. But before that, when one more thing is there, see, this was the case, right? For us, we have uh, we have seen previously, we have entire data set here, right? It was a data set here. So we have some data set here. Initially we have asked some question, let's say fk, which is, let's say, greater than or equal to some theta, and we have two uh, questions, right? Or two answers to it. So it will have yes answer or no answer. Then at the end of s, what will be the fraction? So some fraction of the data set will be on this side and some on that side, right? And let's say that data set we call it as ds, and this data set we call it as dno, as per the. So here, so there will be some entropy at the data set, is that correct?
Yes, sir.
And at the end it will also be having some entropy, right? Actually we are learning something, and that is called as the information gain. We'll try to understand that part, but before that we'll try to see that what is the entropy here. So this was the question, right? We had initially, this was the example we had. What was the entropy here for entire data set? So let's say entropy D is equal to, so as per the formula it should be minus of P log P minus uh,
Plus, sir. Plus.
plus 1 minus P log of 1 minus P, right? What is the fraction here? What is P here? Number of ones. So how many ones are here? 2 by 6,
2 by 6.
right? Then that means 1 minus P will be 4 by 6, or in other words, I can say it is 1 by 3 and 2 by 3. Is that correct?
Yes, sir. Yes.
So here you will have the entropy as minus of 1 by 3 log of 1 by 3 plus 2 by 3 log of 2 by 3, right? At this node and this node, what will be, will that be the same entropy will be there, or it will change?
It will change.
And what should be the fraction here? At ds, this is the ds
Greater.
data set. This is the ds data set, right? X4 y4, x5 y5, and x6 y6. So x4,
Uh,
so this is the
For
data set now.
for yes also it is 1 by 3, 2 by 3 only.
ds, the fraction is 2 by 3. P
P
is now
equal
2
to
by
1
3.
by.
1
Yes,
minus
2
P
by.
equals to 1 by 3. Is that correct?
Yes, sir.
Okay. What about dno? Dno will be which one? Which of the points?
X1, X2, X3.
X3. What is the P here?
See,
Can I say 0?
Yes, sir. But
This is 0.
log of
Log
log
of
of
0 we can consider it at 0.
okay.
Okay. So here you can see there is a convention that log of 0 equals to 0. Log of 1 also will be 0. Fine.
Okay.
Uh, what does that mean? The data set on this side is pure, right?
Yes, sir. Yes, sir.
Can I say it is a pure? Now we don't need actually this. So yeah, we have seen intuitively that we can ask the question, but do we need now to ask any more questions here?
Actually, x less than 140 is also not
Not
needed.
a
No?
not needed question. Yeah, right.
Yes.
Basically, we need to find another question here actually, right? At the end of yes, or at the after this we have s. That means we have some other values here, right? I think the question here is not good, right? The question should
maybe
be,
less than equal to 165.
yeah, maybe that is a good question, right? That's okay. That doesn't matter. But what do you say? What we can now understand that if the data set becomes pure, what we should do? We should
Label
stop,
it.
right?
Stop.
Yeah,
Predict.
we
Give the
can
predict.
directly have the prediction, no, prediction node here, right?
Yes, sir. Leaf node.
So that means this entropy is giving me some kind of hope, right? I think yes.
Yes, sir.
If you are actually if I can understand it now, we should stop. Where can we stop? When we get the pure node, we can stop. That is the something we have got it right now until now. There is another point here is which is called as the information game. What does it give? It gives me the uh, after after asking one question, right? uh, how much I was able to get the information out of that question. Okay, so that gives me the quality of question.
So, how much classification I could do means uh,
Because
how
by asking that question, right?
okay.
So see how many questions you can ask here actually. Do you have any idea about like how many questions? So if you had this kind of data set here, how many questions you can ask? So or how to decide whether how many questions you can ask? So you can actually discretize it into bins, right? So the range is 150 to 170, right? So
Yes,
basically how many questions you should ask here? Maybe you can say that uh, x is greater than 150, maybe
155.
x is greater than 155, maybe x is greater than 160. Like if you can actually bin the data into maybe like how many bins you can, finite bins will be there, right? Definitely the finite bins will be there.
Yes, sir.
Let's say you can ask 10 questions here. So how to check whether these 10 questions, what is the quality of these 10 questions? Based on this information gain
Entropy. Okay,
or
yes, sir.
information gain, right? Entropy, yeah. Basically it's entropy only, it's not like nothing else is there. So that means once I ask this question, right? Let's say if I choose, we don't know, right? We don't know whether which question should be asked. But what you do is you just discretize. So what is the range of this data set? The range of data set is, let's say 140 is the minimum value,
140 to 170.
170 is the maximum value. What you can do now, you can have some beans here, and let's say these beans are 140, 150, 160. Okay, I think okay, I'll just do like simple thing. You can do more, right? But definitely there will be a finite number of questions, right? 45, 150, 160, 170. Okay. Now what happens here? I will ask one question is let when x is greater than or equal to 140, then x is greater than or equal to 150, then x is greater than or equal to 160, and x is greater than or equal to 170. So what will happen after this question? If this was my first question, what happens? You will start growing tree, right? You will have yes here, you will have
So
no
for
here.
the x greater than equal to 140, or that will get one
Yeah,
for
yeah, that's
all
okay.
the.
Yeah, that is fine. That is true. It will not give
And
all one. It will like all the data will go towards yes, right?
yes,
But it
and
will have impurity.
170, all the data will go towards no.
No, but it will have it will also contain impurity, right?
Yes,
Because impurity is given by what? The
but
entropy.
impurity is zero, na sir, for 140 and
No, no, no,
170.
no, no, no. What is impurity? The fraction of ones, right? Like it depends on fraction of ones, right? So
Okay,
when you
okay,
have all the data set onto one side, what happens? It will the fraction will not change, right? It will have 2 by 6 this
okay,
side,
right.
and it
Yes,
will be
sir.
4 by 6. So impurity is not zero there,
Yes, sir. Got it.
right? So that means you have some entropy. Entropy is basically considered as a randomness, or maybe it is not settled down, right? It is not a pure data set. A pure data set will be that data set which will have all the values as ones or all the values as zeros, or values
So
in the sense
can you
labels.
explain that thing again? How there will be how will I mean, how will there be impurity in this case
Okay,
when the
yeah,
entire thing is yes or no?
sure, I'll do that. Let us say you have, I'll just write down it again. Huh? What was the data set? I forgot. But okay, you will tell me that 150, 0, 155, 0, 140. What was that?
0,
0,
160 and 165.
yeah, 160, 165 and
170.
170, and they were all like this, right? This was the data set. Okay.
Yes, sir.
So what is entropy for any case? It
Randomness.
depends or yeah, and it depends on p. P is what?
Fraction of ones.
Fraction of ones. Fine. Fraction of ones in the data set. Is that correct?
Yes, sir.
And formula for entropy of any entropy for p is equal to what? Minus of p log p plus 1 minus p into log of 1 minus p. Is that correct? It's a simple formula.
Yes,
Yes.
sir.
Then we can say that log of 0 equal to 0, that by convention. Okay. Now, in this case, in this data set, uh, let's say you just choose one case, which is which was the question? If x is greater than 170,
170.
or whichever, which one you wanted to pick, or let's say this one, right? Greater than 170, you will say that what will be the answer to this question? Either
All
yes,
of these will be no.
right? So all this will be no. So that means what will be the data set? So let's say this was capital D. Here you will have ds and you will have d no here. Fine,
Yes, sir.
d no.
DS will be null set and Dino will contain
And
all the
when I
data
say
points.
pure data set, is this a
All
pure
of
data
them,
set?
all of the ones should be ones or all of them should be zero.
All the labels should be one, that is a
Or
pure
all
data
the
set, and
labels
all
should
the
be
labels should be zero, that is your impure
Okay, so
pure.
it is
Yeah,
because the labels are still the same. It
yeah,
doesn't change. I mean,
yeah. And
we cannot
you
say
can
that there is
actually,
no impurity.
correct, and you can check through your entropy also, right? Suppose you have, if I, okay, I'll take the ideal case. Suppose you have all ones in your data set. Fine. What will be the entropy of this data set? So entropy will be, what is the fraction of ones here?
one,
1,
one. Yes,
Yes, sir.
6 by 6. That is one.
right? And I'm saying that
6
log of 0 should be equal to 0. So if I just plug in all these values, minus of what is the p? 1
One log
log
one
1 plus
plus 0 log
0 log
0.
0
0.
log 0.
So this is 0 and log 1 is, we know,
0.
0. So log 1 is 0. So that means entropy is 0. That means it's a
0.
pure
Pure.
data set.
Okay, sir. Got
There
it.
is no randomness.
Yes,
And
sir. Got
you,
it.
and if you have this kind of, yeah, right now. So now if you have, this is the data, what was it? I think it was 1 1 and 0. So now every so ds will be, no data points will be there, right? And d no is actually equal to d.
Yes.
So it will have some entropy, right? And what is the value of entropy there? In that case, what is the value of p?
Minus
2 by
into
6.
1 by 3.
And
1
it
by
will
3
be,
log 1 by 3 and 2 by 3 log 2 by 3.
is that correct? I hope it is fine now. And it is some
Yes, sir.
value. It is some
Got
value,
it.
right? It is some value. It
Yes.
is not equal to 0. Unless your entropy is equal to 0, you can't say that it's a pure data set.
Right, right, right. Got it.
Okay.
Yeah.
Yeah.
So
So
here,
that,
here we are not, by asking the question,
hmm,
we have not gained any information here because
yeah,
we are getting the same data set after asking the question. That is, all the points are going towards no.
correct. Right.
So, right.
And so how to quantify that how much you have gained through after asking any question, right? It gives through information gain, and that information gain is equals to okay, you just have to see that after asking any question, right? It should be minus of gamma entropy of ds.
And entropy of the question first, sir. Entropy of the question minus
Okay, so d minus, okay, or entropy of d,
entropy.
entropy of d minus gamma times entropy of ds plus 1 minus gamma times entropy of d no. Okay, what is gamma here?
Fraction of data points going towards
Yeah,
yes.
fraction of data points. Uh,
Going towards yes.
yeah, so which are there in the s, right? In ds. Can I say uh, in DS, right? In that data set. So DS will also be a data set, right? So let us say I have asked the question like this. So I'll just again
So, sir, I think you should ask between 155 and 160.
yeah, we'll try to see there. Sorry. Where is this point table? Okay. Sorry, just give me 1 minute. Let's try to. Okay, I hope this is fine. Ah, okay, so now uh, I'll have to find out. So let's say what I said. How many questions I can ask? I will discretize it into bins between the range, right? Now let's say another question is. So the question is, so you have some data D. What is the entropy of this data set? Entire data set? Can I say that? Oh, what is the fraction here? 2 by 6. Basically, it is minus of 1 by 3 log
Log
1
1
by 3 plus 2 by 3
2
log of
by
log
3 log
2 by 3,
2 by
right? This is my entropy of entire data set. Now the first question I asked is, let's say x is greater than or equal to, let's say 155. Is that fine? If I ask this question, I'll have yes and no answers, and we'll
3
have
points will go towards yes and 3 points will go towards no.
okay. So yeah, so I'll just write down data set. So what will be ds here? Which three data points? Uh,
Greater than or equal to or greater than, sir?
let's say
Greater
whatever,
than
whatever. Let's say greater on. We
4,
don't have
yes.
to worry. We don't have to worry. Let's say. Huh?
So 3 will go towards yes and 3 will go
Okay. So
towards
which one will go? Let's say. Uh,
160, 165, and 170.
so x4 y4, right?
X5, Y5,
x5 y5 and
X6,
x6
Y6.
y6. Similarly, d no will be which of the data points? It will be
Y,
x1
X1,
y1, x2 y2, and x3
Y3, Y3.
y3. This will be the my data set. So what is the entropy of ds, right? What will be the entropy of ds? So what is the
Same, sir.
fraction of it will be same, right? What is the fraction? So this is my ds data set, right? So p will be 2 by 3.
2
So it
by
will be
3
minus of uh, 2 by 3 log
log
of
2,
2
2
by
by
3 plus 1
1
by
by 3.
3 log of 1 by 3. What will be the entropy for d no?
It will be pure, so it will be 0.
Entropy of d no will be uh, minus of, what is the fraction of ones here?
1,
0.
0.
So it is 0 log 0 plus. I hope you guys are with me. Like I'm
1
just
log 1.
hearing only one person's voice, but I'm assuming that everybody is following this place with me, right? This
Yes,
okay?
yes, sir.
Okay, so this will be 0. Okay, that means no side we have uh, pure data set right now. So shall we ask any more questions further here? Not required, right? Because already we have got that perfect classification on that side. But shall we ask any more further questions on this side? Possibly, yes. So what will be my next question? It might be x is greater than 165, right? And it will have yes and no, and then we'll say that with what is the labels. Fine. But what we have gained after asking this first question, right? Because we need to see that what is the quality of question, right? That was our important discussion, like important part when I started this discussion. So when this will happen with this information gain. So information gain is actually equal to minus of gamma, sorry, not minus, d minus entropy of d. So
Entropy of
entropy of d minus uh, gamma times
entropy
entropy
of
of ds plus 1 minus gamma times
entropy of
entropy of no.
D naught.
Okay, what is actually this equation suggests to me? So whatever the entropy we have got through this, right, into we'll have to see what fraction, because s is the, let's say s is the important question to me. uh, so this will give me what, the total randomness when I split the data set into two. Is that correct?
Yes, sir.
And what you have to do now, whatever the actual at the initially whatever that entropy was there for me, if I subtracted the entropy after the two, like after once we divided it into two groups, if it is, when I say that I have gained something, if that value is positive or if that value is negative.
When randomness decreases, that's
Yeah.
when you say that you are gain something.
Right. So what is what, when it will, when we say that it is good.
When after asking the question, all the
Hmm.
ones go towards
Zero.
one side and all the zeros go towards the other
Yeah,
side.
but with information is what will be the good value to say? Will it be positive? Will it be negative? Will it be zero? What is the
It
answer?
will always be positive, right, sir?
Entropy of D should be like more, right? What we know that if it is more, then it is good, right? If
Yes,
it is
sir.
more, then it will be good. If it is not more, or it, so that means information gain will have values. Will that be zero? Yes. Yes. Which question it will be zero? Can I say the question, if this question is x is greater than 170? Can you say that in this question it will be zero?
Yes, sir. Yes, sir.
Now think about it. Yes or no?
Yes, it will be zero because initially also it is the
Now what is gamma here?
entropy before asking the question and entropy after asking the question.
Uh, it
They
is
are the
remaining
same.
same, but how this gamma will play the role here?
Gamma will be zero for one and one for the
Hmm.
other, right?
Correct.
Gamma.
Correct.
Yes.
Because there in that one greater than 170 question, on the one side we have
No
zero
value.
values. So no values. That means it does not have any fractions of. So okay, what is gamma here, right? So that is the important thing. Gamma is
Fraction of yes is in
fraction
fraction.
of number of
Yes.
data points which are there in the, so this is the cardinality of ds data set, right? So how many values goes into, or how
Yes.
many data points goes into that s data set divided by total number of values, that gives me gamma. So the minimum value of this information gain will be 0, and it will be more, like it will be positive, right? If it is positive, then that means you have gained something after asking that question, correct? And you will choose which question, the question which gives you the
Maximum gain.
maximum information gain. I hope this is fine. What happens next? Let us say you had this initial data set, you have one question, let's say x is greater than something, let's say a, you have s, you have no, you have some ds data set here, you have say d no data set, let's say this is a pure data set. What happens here next? You'll have some, let's say you have more features than one, so x1 is greater than a, maybe x2 is greater than b, and then again you will have some yes and you will have no. What will be the information gain here, here at this part? Let's say it is ds2. uh, how you calculate the information gain at this point? Will it be this minus this, or the entire minus this?
ds minus ds minus ds2.
ds minus ds2,
Yes.
right? You don't have to now worry about the entire thing, right? Because it will automatically will be taken care of.
So
We
we
can
are
actually find out.
concerned about asking
Yeah,
x2 greater than b, right?
correct.
So information gain. So information gain is for a question, right?
for a question, so particular question, so you don't, so for that question that ds is a complete data set, right? Now
Yes.
after dividing it into the two, whatever it will be, whatever the values will have, or whatever the information you have gained, you will calculate there. So, and when to stop now, when to stop to grow a tree, it can
When
go
we get
forever, right?
pure, when we get pure data
Pure,
sets.
that is one aspect of it. But let us say if you have so many let's say if it is if the trees goes to 100, right? 100 like 100, you need 100 questions to get the pure data set. And suppose you can stop where, you can actually stop at some point where you can see that okay, this is a good amount of information you are getting. Suppose okay, in this case, let's say in this case itself we can see that once I can stop at the first question itself, right?
Yes, yes.
Because this might be outlier, correct? If I try to grow one more tree or one more uh, what is it, branch there or node there, what will happen? It will try to overfit to this data, right? It may be outlier, right? If I can ask at this question, will that be sufficient for me?
Just
It
one
is
question.
sufficient. Yeah, I think it is sufficient for me, so I don't need to go. So let's say you have 100 questions such that, and suppose at 80 questions itself you are able to classify it like at certain satisfactory level.
So by asking this question x greater than 155,
Hmm.
we have actually the information we have gained is half the information, half of the entropy which the question had, right?
Correct, correct,
So
correct.
yes, yes.
So that
We
means we have gained a lot, like gained enough, right? So this depth of the tree is a hyperparameter. And what I said about hyperparameter,
validation you have to do for that.
yeah, cross validation is you have to do, and that means you don't learn those hyperparameters. What you have to do, you have to take a trial and error, or that is called as a cross validation, right? That is a cross validation technique, and
So
based on that,
sufficiently pure depending on our requirements, sir.
yes,
Sufficiently.
sufficiently pure is our requirement. Only pure is when the tree will like finally gives you like proper, it will give, right? What do you think? The decision tree will give you the pure data sets. Yes, right, we can ask like lot of questions, and definitely at some point of time it will give me, right?
Right, sir.
For
But
any data set, for actually for any data set, it can go till you will you will get the pure data set. It's fine, right? And
sir, one question I needed to ask here.
hmm,
We are asking the question in the form x is greater than 155, or suppose we have two features, then we are asking x is greater than so and so, or y is greater than so.
yeah, so
Can we
here
ask x plus y is greater than so and so?
x plus y. Okay, what do you mean by x plus y? That labels
Suppose we have two features. We have two features,
x1
x1.
x2.
Yes. So,
Okay.
so we are generally asking x1 is greater than, we question
No,
like,
I think we can't ask x1 plus x2, because
okay,
then that will become a new feature, right? You have x1
okay,
as a feature, another is x2. So x1 plus x2 will be a new feature. So that means you are adding one more feature into the data set. And now based on that, you are asking the question, right? If it is inherently present in the data set, that might be possible.
okay,
But again, you are actually increasing one more feature, right?
okay, okay.
Yeah. So I
So
don't think that is.
questions like x1 plus x2 greater than something is cannot be asked.
It's not like cannot be asked. That means you are actually adding one more new variable, right? And then you are doing it. So do you need that? That is the thing, right? Generally, for why we learn PCA, to reduce the dimensionality, right? So now
Yes,
you are, what you are doing, actually asking one more question, you are actually increasing the dimensionality of the data set, right? So
yes, yes.
is it computationally required or not? That is your part, but generally you don't do that,
Okay.
right? It's not
So
like you can't
at
ask.
one time,
I'm not
at
saying
one
that you
time,
can't ask.
okay. At one time you ask question on only fee based on only one feature.
Yeah,
At
yeah,
one,
yeah. Yeah, but again, see that another question, x1 plus x2, does it make sense? That also you will have to see, right? Practically, it's not like this two values are
It
there.
will also divide the data set into two parts, right, sir? X1 plus x2 if you do x1 plus x2 greater than so and so. That will also divide the data set into
Y-
two parts, right?
No, no, that is okay. So number wise, there is no problem, right? So the two challenges which I feel is, one is whether that x1 plus x2 makes sense. Another thing is whether uh, adding one more dimension to your data set will be valuable or not, right?
Okay.
Because it is increasing your dimension adding. I hope this is clear to all of you. This will be the so this was like f1 is height and f2 was weight. So how the questions have asked, right? It is there. So you can watch the lectures. You may be able to understand better.
So
Okay.
here one feature is less than 5.
Hmm.
So can you go to that graph here?
Hmm.
So first they have asked f1 is less than equal to 5.
So that
So
means it is divided into this side, right hand side of this, and the left hand side of this,
right,
right?
right.
Of
Second
x-axis.
second question they are asking f2 is greater than 7. So
Less
if
than, less than.
if
Less,
yes,
less.
then
F2 is less than 7.
so this line, yes.
This one, and then this above. It will like, and once it is no, you say 0. If it is yes, then you ask one
Less
more
than
question.
3.
Yeah,
F1 is less than 3. Okay.
right.
Right.
So you can
And
watch the lecture. It is already there, so it's there. Fine.
so, sir, if we ask a combination of the features, then it will not be a straight line. It will not be a vertical or horizontal line. It will be a slanted line in that case. If we ask a combination of
Yeah,
features.
but that's what I what I feel. Yeah, the decision boundary will be that part, but I don't think that will be the good approach, which I feel, right. So the what I said is, maybe these two are the challenges there. One is increasing the dimensionality. Another thing is, if see your data set, when your training data set is there, the labels are with respect to what, x1 individually and x2 individually, right?
Yes,
They
yes.
are not with respect to x1 plus x2, right?
Okay.
So your data set, the labels which are given to you, this is a supervised learning algorithm where your output label is based on x1 and x2. So y is dependent on x1 and x2. Y is not dependent on x1 and x1 plus x2 inherently, right?
Yes,
So
yes.
that is a problem there. Okay. Okay, so I think I have covered most of the concept. There is one more concept which is left, is this one. So I think that you just study it first. Uh, it's not much more here in this case. In this week, we'll have to talk about much more about generative models and discriminative model the next week. So if you have time, you can just go through it. Maybe we'll discuss everything about it in the next week. Generative and discriminative model. Fine. Uh, okay, I think I'll stop here for today. I hope you understood some part of it. If you go through lectures, I think we'll be able to. Yeah, what is happening? This house thing, I don't know. I have got the news about it. Like I'm not sure about it. Some houses are actually covering some sessions, right? I don't think. I think so. Have any one of you attended those sessions? MLT series. Okay. Okay. So do you find it useful? Or okay, they are mostly talking about uh, PYQs. Okay. Do they cover the theory part of it?
Which houses are doing that?
I think some of the houses are doing, or every house is doing. I'm not sure, because we have got to know that. Like it's not coordinated with us, so I'm not sure about it. Yeah. How was it? The session? The problem is that there is a confusion between the people, that whether it was a TA session or instructor session or like something like that. It's already there in your calendars. Somehow it is there. We'll have to look into it more carefully, right? Yeah. How was the session? Who was Chandrasekhar? Yeah, you attended, right? Good. Okay, fine. Okay, so do you think, like, if the sessions are doing, yeah, that is unofficial. That is what. Uh, so I'll be little bit worried when it comes to uh, If the TA sessions are there, we know that there are the TAs which are chosen. If they are not, we'll see. We'll see how we can do about it, right? Yeah. Thank you, guys. Good night. I hope you found out like somewhat useful the today's session. Let us continue our discussion.
Yeah. Yes, sir.
Okay.
Thanks a lot, sir.
Yeah. Thank you, guys.